Welcome to Russ the Coder's YouTube channel. Today we're talking about Big O Notation Simplified. This is a very simplified video on Big O Notation. It is not going into greater detail. There are plenty of other great videos on YouTube. The problem with many of them are that they start out too intense and just start confusing everyone, especially me when I started. So Big O Notation simply tries to explain how many operations or time some code takes to execute. Also how this time changes with bigger inputs. So we're basically saying how long a piece of code takes to run as the data input gets bigger and bigger. And what do we need Big O Notation for? There's a couple of reasons. The biggest being that as you begin coding through your career, you could start seeing the same kind of patterns over and over, and you could start picking out the best ways to write a piece of code over a collection, usually, so that it could run faster and that it doesn't get bogged down unnecessarily. The other reason is because it is brought up in a lot of interviews, and although you may not think it's a real world type thing, it really is. So arrays. You probably know what an array is, so you can understand Big O Notation. There's a couple random JavaScript examples, array of numbers, letters, and some objects. So we'll just start out with a very simple example with, and not even really talk about which specific notation it has. So we have a function that all does is loop through an array, and this is in JavaScript, all these examples are. So we call it twice, first with this input of 1, 2, and then 1 through 7. It takes longer to execute the second time. That makes sense because it is a larger array. That is really what Big O Notation is. It's trying to explain why it's slower and how much slower as we get these larger inputs. The different notations, there's plenty of them. There's actually more than this. The three main ones we're going to talk about are O of 1, which is constant time, O of n, which is linear time, O of n squared, which is quadratic time. Of course, there's O log n log n, etc. O1 constant time is the simplest to understand. So the number of operations is the same regardless of the size of input. It is very fast. As you can see on the graph, it is just a straight line right across. Here's the JavaScript example. There's just two little simple integer arrays. The first value here, we're just getting the third index, which is the fourth value, and the seventh. These are two small arrays, but even if the second array or each array, whatever, was extremely large, this will be the same time to get these values because we're just getting one value out of here, one index. So it's the same time regardless. And this is O of n, linear time. The number of operations is proportional to the size of the input. So basically, the input grows by 1, the operation grows by 1. It's just a 45-degree angle up. Here's a JavaScript example. This is just the same one as we saw on the simple slide a few slides ago. All it is a for loop right over the array, so which makes sense because as you add one item to the array, so one larger input, it will be one more iteration, and so one more operation, and just scales upward. O of n squared, quadratic time, the number of operations is a square of the number of inputs. This is also very simple. This is just two arrays. We're going over the first array and then going over the second array inside of the first one. So for every iteration of the first array, we are iterating over the second array. And in this example, we're just adding up every integer in the first array to every single one in the second array. And that's it, just to show an example. This is quadratic time is really common if you go up to like the LeetCode or HackerRank type things and trying to manipulate two arrays together. A lot of those are quadratic time. Like I said before, there are many more notations, but those are just kind of a simple few to get into it. One resource here is bigocheatsheet.com. It is a great resource. As you can see, it has many different of the notations and nice charts to see as you go up in size, how the different notations grow from excellent to horrible time. All right, well, that's it. Thanks for watching.